All right, recording started. Over to you, Guillaume.
All right, so thanks everybody for being there today. So that's my pleasure to introduce you to this code lab on Gemini in Java. So as I was saying, lots of enterprise applications are written in Java. So if you want to take advantage of large language models, you'd like to be able to do that in Java in order to integrate that into your Java applications. So that's why with my Java hat on, I decided to see what I can do with Gemini in Java. So this code lab focuses on Gemini. We will, at the end, also have a quick look at Gemma, which is an open weight model that you can use and run even on your laptop, not necessarily calling the Gemini API directly in the cloud. So Gemini is hosted on Vertex AI. Vertex AI, that's really the offering of all the machine learning products of Google Cloud. So when you hear Vertex AI, it's lots of things, and it includes the Gemini large language model. We will use, so there's actually a Java, or I'll say that again later, but there's also a Java SDK that you can use to interact with Gemini. But there's also a great framework, LangChain4J, to interact with large language models, but also other things like vector databases and things like that. So we'll use that particular framework to interact with Gemini in this code lab. So a quick introduction or a high-level overview of generative AI. So generative AI refers to this field of artificial intelligence that is used to create new content. You can generate text, you can generate images, and other sorts of outputs. What's interesting with generative AI, let's say to contrast with what we could do before with other machine learning approaches, is that it's not just about prediction, like, whatever, let's say, what's going to be, like with a statistical model, what's going to be the price of this house in that region or something. Here we can really generate stuff. We can really generate text, for example, like if you want to say, okay, help me write an email, you can ask Gemini and it'll try to generate an email that is complying with your request. And for that, some new neural networks architectures have been created, the transformers neural networks, to allow that kind of tasks to generate text and other modalities. And LLMs are great at lots of tasks like creating summaries of big text, big articles, etc., doing question and answer, potentially from pictures, in the case of multimodal models. So when I say multimodal, it means not just text, but text, audio, images, etc. And classification, etc. There are lots of things that we can do with large language models without being an expert in machine learning, because you as a developer, you just have to use an API. So that's what we're going to see. Also very quickly on how generative AI works. So as I said, it's a kind of think of it as a black box, but under the hood, it's neural networks, etc. But what's interesting is the way it works is that it analyzes lots of text, lots of images, etc. And it, for example, for text, it thinks in terms of tokens. So it's like words, but it's usually smaller than words, and tries to understand the relationships between the words, between the tokens, and try to generate the next token according to what was generated, what the question was asked before, what the article that we gave it was about. So it's a kind of statistical model that predicts the next words in order to be able to generate text. Some concrete use cases of generative AI. So probably the most famous two use cases that some advanced, clever, smart chats experiences. So you can chat with your own documentation, with, for example, the documentation on your website of your customers, etc. It's also great for search experiences, like semantic understanding of past requests and all sorts of searching through, I don't know, let's say if in the medical field, it could be searching through patient records to find similar patients with the same illness or something and try to understand what the symptoms are or things like that. You could think about that. And it's really great at going through lots of unstructured data, because it's commonly accepted that the data that is structured represents only maybe 20% of the data, like in databases, JSON files, CSV files, etc. But vast amounts of data is just text in articles, in documents. And LLMs, large language models, are great at going through those unstructured documents to extract structured information out of the box. Yeah, so what generative AI offers, well, what Google Cloud offers in terms of generative AI, as I said, all our machine learning products are part of the Vertex AI collection of machine learning products. You can use different LLMs. There's a model garden which contains lots of models that you can use, and not just Gemini. There's a studio where you can try your prompts when you interact with an LLM. You can also create notebooks in Python, though not in Java, to start coding with LLMs. You can create chatbots, search engines, etc. And Gemini, it's not just one model, but there are also, let's say, derived products. For example, when you're within the Google Cloud Console, there's Gemini for Google Cloud. It's a chatbot that knows about Google Cloud. It can help you through the tasks that you have to do, like, hey, how can I scale my Kubernetes cluster? You can ask such questions. In your IDE, there's Gemini Cloud Assist, which allows you to do code completion. Hey, help me create this algorithm, etc. So there are lots of tools at your disposal as part of the Google Cloud Vertex AI offering. So Gemini, it's the most capable model that was built by Google DeepMind. It's multimodal because it understands text, code, images, audio, video. There are three, well, I should say four, actually, three variations for sizes of the model. So Gemini Ultra is usually the biggest model, also usually most expensive as well. Pro, it's a very, very good model that you can use for lots of tasks and even for advanced reasoning tasks. Nano is the smallest of this family of models, and it can run on Samsung S24, or I forget the right version, smartphones, or Pixel 8 smartphones, etc. It can run on device. And today we're going to use, so it's not in the list, but Gemini will use mostly that model, Gemini 1.5 Flash, which is pretty much as powerful as Pro, but is super efficient, generates text very fast, and it's a good, let's say, bang for the buck, in the sense that it's a great price for its capabilities and its speed. As I said, part of the key feature, there's multimodality, the fact that it understands different kind of inputs, not just text, images, etc. It's pretty performant and yeah, flexible. So as a Java developer, we want to integrate the LLM. We want to integrate Gemini in our applications. So how to do that? Gemini is also an API, so you could also use like a REST endpoint and create your own request to that REST endpoint. But you also have an SDK in Java that is available. So that's the Vertex AI Java API for Gemini. But here there's also a higher level framework called LangChain4J, which is an open source framework, not developed by Google, but that, well, I contribute to that framework myself, so we could say it's somewhat supported by Google in a way, because I help with the Gemini integration. But we'll be using that framework for this code lab. And so this is the blurb from the GitHub project. So LangChain4J is a framework that allows you to integrate different things together: large language models, vector databases, create prompt templates, chat memories, etc. And it has a really nice logo. I really love this little parrot drinking some coffee. All right, so that's about it. So what we'll learn, so we'll need to set up our project a little bit, but then we'll dive straight into how to ask your first questions to the model, how to stream responses if you want to see the model generate tokens by a token. We'll do a chat conversation. We'll see how you can send text and images. We'll extract structured data out of unstructured text, create prompt templates, etc. And so what we'll need, so you already have your Java project. We're gonna create a Java project, a GCP project. So we're going to use the Google Cloud Console for that. And yeah, the browser. We're in the browser, of course. Next step. So you should have already the steps in step 2 here. Most of the steps should already be ready because you've just selected or created a project. So this is so I can show you the console as well at the same time. So here I have my project already pre-selected. And important, we'll need the project ID, and we'll use also, well, I'll tell you later on, but we'll also have to have we'll save that project ID in an environment variable, and same thing for the location, the region of the project that we will be using. So in order to start, we'll work in the Cloud Shell editor, and to run the Cloud Shell editor, you'll see here at the top right-hand corner, you'll see this little square icon with the greater than sign. So you'll have to click on that. Here I'm just at the dashboard, the main page of the project. But if you click on activating Cloud Shell, so it might take a little bit of time if it hasn't been created in your project, but it's going to provision a virtual machine with a terminal, etc., that you can use. So we'll use that. So I'm going to maximize that. So I launched.
Sorry to. Yeah, it's me. I was just going to say, everyone at this point, please start your hands-on implementation and follow along. Guillaume, after every step, you probably just everyone, if you're able to, just use the emojis to show thumbs up so that Guillaume is informed that you're all following along, and use the chat for questions, please. Thank you so much. Sorry, Guillaume, carry on.
No, that's great. Thank you for the reminder. So yeah, I'm starting Cloud Shell. It's actually already started now. And so what we'll do is to double check. So you can run those little comments that are mentioned in step 2, but normally if you see the shell with the name of the project in yellow, usually that means that your project is already ready. The shell is configured with your project. So in the commands, it mentions like auth, the gcloud auth list to check if you're authenticated. So it can ask, do you want to get authorized? So you say yes. And so it should say we're authenticated. So this is my demo account that I'm using. So that's great. And the other example, the other command that is mentioned, that this one, config list project, to see the project that is currently active. And usually, as I said, you should see the project in yellow. If it's not the case, there's a command that you can use, gcloud config set project, and the name of the project ID, sorry, that you should see here. So for me, that's the one that's currently selected. But so I don't have to run this command. All right, so that's really the first thing, having the shell ready there. So I'd like to see some thumbs ups or down if you manage to launch the Cloud Shell editor, the Cloud Shell terminal. Okay, perfect. Lots of thumbs up. Thank you. So it leads us to step 3. So there are, we'll need to use the Gemini API. So for that purpose, we'll have to enable some APIs on Google Cloud. So the key API that we need, it's called the name of the API, aiplatform.googleapis.com. And there are different ways to do that. So one way is to run this command line. The other way is just to go when you search. So I'll close that. For example, if you search for Vertex AI, it should bring you, no, that wasn't the one I wanted to do. This one, Vertex AI here. And normally, if it's not enabled, you should see something like Enable API, okay? So click Enable API there, or if I come back to the shell, you can launch this command here. For me, as I said, it's already enabled in my project, but oh, there's a, what's going on? Yeah, there's a permission denied, but normally it's because it's already active. With permission denied, that's interesting. That's not what I expected, but normally you should be able to enable the APIs. So same thing, thumbs up if the Vertex AI API is enabled. One thumb down, 3, 4, oh, a few thumbs down. So be sure, yeah, to normally Vertex AI, and you should see the little screen suggesting to enable. Yeah, more thumbs ups. And so there was a question. Feel free to ask the question in the chat. Okay. So let's move on. So we have the project ready. So the next thing is we're going to clone a GitHub repository, because all the code that we're going to go through is available on GitHub, on my repository here. So in the shell, let's run this command, git clone, and the URL of the workshop. So where I am in my home directory, so that's great. And let's clone the repository. So it should have created, I've got lots of things. It should have created this directory, Gemini workshop for Java developers. So you have to cd into this directory. So that's what it says here in the instructions. And then, so we're using Gradle, the Gradle build tool for this project. So depending on the environment, sometimes you have to recreate the Gradle wrapper. That's what allows you to use Gradle with a particular version, the same one as defined in this project, basically. So there's Gradle already installed on Cloud Shell. So I'm going to create the wrapper, and then we can use the wrapper with /Gradle w afterwards. So it's going to create a wrapper. That's w for wrapper. And then, for example, if I do Gradle tasks to see what's available, it should run the version that comes with the project. So that means that my Gradle installation works. And actually, yeah, a better test, you should just do Gradle run, and it should say, it should compile all the code of the project, and it should output hello world. So this is not yet using Gemini, but it's just to ensure that the project runs fine. All right, so is everybody able to run the Gradle run command? Okay, one thumb down. Don't hesitate to share in the chat when you have problems. Okay, looking good. So depending, so there may be different versions of Java installed, but normally out of the box there should be this version, but maybe it's not the default I'm already using different versions of Java in my environment, so I'm not always sure which version is available by default in your project. So potentially you may have to run this command if you see some errors that says, yeah, it's not using the right versions of Java or something like this. But for now, I don't need to use that. And so we were in the shell, but we're going to use the built-in VS Code editor. And to do that, we're going to click on this button, Open Editor. So it's going to provision the editor, and voila, I'm in the built-in VS Code, basically. And as you can see, there's even my folder, which is already there. Okay, open. No, that's fine. Right. We're going to come back in the terminal for one little but important thing, that's exporting two environment variables, project ID and location. So I'm going to copy paste those two commands there in the shell. So if you want to switch between the shell and the VS Code, you can just click Open Terminal, Open Editor, etc. to switch back and forth. So if I do this, it should figure out that the project, let me echo project ID because I used the gcloud command, and you see that, yes, my project ID environment variable contains the name of the project ID of my project, and well, the location. I'm using US Central one, but you should be able to use other regions potentially if you really want. Okay, and so this step, I think it's not necessary to do it because we won't really need the Gradle support within the VS Code, etc. And normally VS Code comes with Java support already out of the box. So you should be able to just open the sources like this. For example, yeah, there's a question maybe.
Guillaume, so I was just trying to, that was not me who raised the hand, but anyone, if you have questions, please use the chat. Guillaume, I just got a request on the chat asking to go a little bit slower. So
okay,
yeah.
Sounds good. So yeah, the final steps, normally you just need to be able to look at the code, not necessarily edit the code, so you don't have to install extra plugins out of the box. Yeah, the comments, the comments that I showed were just so I did the export comments that you saw. Sorry, so going a bit down here. Yeah, so that was those two comments that I ran to get the environment variable set up. And then it's not written in the CodeLab instruction, but to be sure that the project ID and well, I can just go back in history. Project ID and location are properly set up. You can say echo $ project ID, echo $ location. Okay, so those two ones. Okay, so are you able, so do you have those environment variables ready? And can you see the code in Gemini workshop for Java developers /app/src/main, etc.? Yep. All right. So when I run Gradle W run, you saw in the output hello world. So that's actually this first message that you saw, but it's not yet using Gemini. So we're gonna be able now to move to step 4, and we're gonna have a look at the first example. So for the first example, we're gonna ask a simple question to Gemini. Okay, so we are going to open the QA example here in the terminal, in VS Code. So there's a license header, we don't care about it. we're importing a couple of classes, and you have a class and a main method. And there are only actually 2 instructions in that. Maybe I'm going to increase the font size a little bit. There are really only 2 things to do in that first example. First, we're going to use LangChain4J's integrated support for Gemini. So we're going to create a chat model, which is actually a Vertex AI Gemini chat model. And this class comes with a builder to configure the model. There are a few things we can configure: the project, the location, and we'll pick up the name of the project and the location from the environment variables that we set up in the shell. Okay. And we'll define, so we'll use I think in almost all of these examples, we'll use Gemini version 1.5, and in particular, the Flash version of the model. So that's a very fast and a very cost-effective version of the Gemini models. So once the model is ready, we're going to call model.generate and pass a simple string, a question, and this method actually returns a string, and we'll be able to print that string in the output of the terminal. So let me come back to this. So you saw the code in VS Code as well as in the instructions. And we're going to copy this command line command here, Gradle W run -q and -d, and this attribute Java main class equals the fully qualified name of the class. Okay, so let's just copy and paste this and see what it gives. So I'm in the editor. I'll switch back to the terminal. I'm going to paste this command, Gradle W run -q. That's in order to avoid seeing the output of the Gradle build tool. So we're just going to see the output with our system out println instruction. And then we're going to say, okay, we want to run this particular class, the QA class that we opened in the editor. Okay, so let me run that. And let's have a look. So Gradle is compiling or checking that something has to be compiled or not. And you should see in a few seconds the answer. So why is the sky blue? So the sky appears blue due to a phenomenon called Rayleigh scatterings. So, well, I'll spare you the details, but it explains why we see the sky blue. Well, when there are no clouds, obviously. Oh, there are some build failures. If you have build failures, I'd be curious to know what kind of errors you get, because you might be getting them. So warning, permission denied, API method requires. So, okay, so it seems to be related to the fact so Abby explained how to enable the billing. So you have to come back to that. So, build failed with an exception, APRA, Java 21. So the first one at least is really because your billing hasn't been enabled. So I can just come back here. So when you were, billing, in the billing support, I don't want to see that here. Billing, wait, where is it? Is it in billing? I forget. Billing method or billing overview? I never know. So you should have, as Abby explained, somewhere. Well, I don't have the same billing account, etc. So, so maybe check with Abby in the chat to remind about this.
It was a credits option in the menu that you.
Okay, it was in the okay. As I'm not the same things. Okay. Oops, I need to reconnect. Oh yeah, and by the way, if ever Cloud Shell times out or it says reconnect, sometimes it forgets about the environment variables that were set. So here it seems it remembers, but sometimes after a long time, sometimes the environment variables kind of disappear. So you would have to check that. For the other errors I saw in the chat, there was an instruction in step 3 that maybe can help. That was this one, which is about the fact of using Java 21, because this Codelab is written for Java 21, although it should work with other versions of Java. Maybe, I don't, the strict minimum maybe 17 or something like this, I'm not sure. And when you do that, you should see, or for example, when you do which Java, it should say, oh yeah, no, I need to do, or let's say Java version maybe. It should say, okay, now I'm using this version of Java. So maybe try that command that you can find in the green box in step 3. Okay. So I'll move on. Hopefully this will be good enough. Oh yeah, someone using Command G in the editor. So I'm using the Cloud Shell terminal, but also in VS Code, if you use Command J or Control J if you're on Windows, there's also a built-in terminal. So it's possible to use that terminal as well. I used Cloud Shell terminal because usually the font is bigger, but it doesn't matter which one you use if you're happy with the other one. All right. So yeah, something I wanted to mention. I think it's mentioned at the end of step 4. Oh no, yeah. So that's I'll say that later on. So when you saw the response appear, okay, some more build fails. Time period for environment variables for reconnect scenario. So usually, I don't know exactly. Usually it's about a few minutes. But for example, I switched tabs and I could just reconnect directly. It hadn't forgotten. So it's more for after a long period of time usually. All right. Yeah, and then export location. Yes, that's the correct command, and it's explaining step 3. Right. And yeah, so and then the comment may be tried if you see the same error that Shreyas mentioned, for example, because I think it's not very detailed, but I think that might be related to that. All right, process command, OpenJDK. All right. Please explain the use of LangChain. Yeah, so LangChain, so I think that was in introduction. So LangChain is a higher level kind of framework, not just to invoke an LLM, but also to do other things like we'll see that a little bit later on, but how to create vector embeddings that represent vector representations of words and phrases, etc., to interact with vector databases, to create prompt templates, to have reusable text, and you just have to fill in the blanks, to handle chat memory. But we'll see some of the capabilities of LangChain along the way. If you were to use the Gemini Java SDK directly, usually it's more work to reinvent what a higher level framework does. Okay, so let me come back to step 4, and there's a second part to step 4, which is the stream QA Java example. So instead of QA, we'll open stream QA this time. And as you'll see, we're creating a streaming chat model, not just a chat model, but a streaming chat model. So that's the same parameters, except this time I added a new parameter, which is max output tokens. For example, I don't want to generate a too long response. So I'm going to just say, yeah, restrict to a maximum of 4,000 characters. But otherwise, apart from the class and this new configuration option, it's similar to what we had in the QA class. But instead of just passing the question to the generate method, we are going to use the streaming response handler as a second parameter. And you remember that for those who managed to run it, in the shell, the response appeared in one go directly. Here, we're going to be able to show the response appear step by step, token by token, or sentence by sentence. And there are two methods on Next. For each new sentence or a few words, it's going to print the currently generating response. And in case there are errors, you could print the stack trace, throw some error or something like this. So this is a little bit more verbose than QA, where you could just say println and the return type of generate. But here, we are going to generate token by token. Yeah, so what is a streaming chat model? That's the fact of interacting with Gemini, but and letting it generate the response as it's being generated, without having to wait for the generation of the whole response before showing that whole response. You can start showing the response in pieces. So if I run that example here, so with this command, Gradle W run Q and stream QA. We're going to run that in the terminal. Going to clear that a little bit. So you will see that the response will appear sentence by sentence, right? You can see that it's not appearing in one go. So you have the steps appear progressively. Okay. Yeah, and if the few, as Abby mentioned, if you still have some build issues and so on, just follow along by just looking, because it's with the number of people we have, it's going to be difficult to debug those problems, and you can come back to it later on. So that's it for the first interaction. And there are a few extra parameters when you configure your model. So in the second example with the streaming approach, we said max output token to say, yeah, give Gemini a limit to the number of tokens that are generated. But there are other things like if there are errors during the generation, you may want to retry, or those three parameters which are interesting, the temperature. So it's a number which you can specify to say, I want a very a more deterministic, a more factual response to be generated. So you would choose, for example, 0, or you may choose 1 to say, yeah, no, I want something that is more creative. So if you want to generate stories or something like this, or articles, etc., you may want to put the temperature at a higher value. Top P and top K, I won't dive too much into the details, but when an LLM generates the next token, the next word, it knows that, oh, well, there are maybe 40 different words I could pick from, and I'm going to use a random value to say, okay, I'm going to pick that one. So you can influence the number of tokens among which to choose, and the probability as well of which token to use, the cumulative probability. So maybe the first 3 tokens will represent 90% of all the probable next words. And so you may influence those parameters. So sometimes it's a bit experimental to see what works best for your own example. But already even just using the temperature is already a good thing if you want to try different things, different outputs. All right. Did you manage? So some thumbs up for those who managed to run QA and stream QA classes. Okay, that's great. Awesome. So let's move on to step 5 now. So we just used Gemini for a simple question and answer, but a big use case for LLMs is to create chatbots. And for chatbots, you're going to ask something, receive a response, ask something else, continue receiving responses from Gemini, etc. So it's a multi-turn kind of conversation back and forth between the model and you, the user. So let's have a look at the conversation class. So there are a few new things here. So we're going to use, like in the QA class, we're going to just use the chat model, not necessarily the streaming model, because I find the text to be more, or the code to be more succinct and more readable that way. But you can also use streaming, of course. So we prepare the chat model, just like before. But there's a new component here, the message window chat memory. So this is a new component which is part of LangChain4J, which allows you to create a memory for the chat conversation, because LLMs are actually stateless. So when you have a chat with an LLM, you have to send the whole conversation, not just the last question, but the whole conversation, the first question, the answer, the other question, the other answer, etc. And LangChain4J shields you from handling that state management thanks to chat memories. And here we use one particular chat memory, which is message window chat memory, which allows you to specify that, yeah, you just want to retain the last 20 messages in the chat, because you don't necessarily to keep the whole context at all times. So this is also a way to save on the tokens that you use, because the more tokens that are generated or given to the input, in the input of the LLM, also it's more expensive. So we're going to use chat memory, and here we're going to prepare our own interface. It's up to us to define the contract of that interface. So here I want to do a chat. So I'm creating an interface that contains a method with that kind of signature. LangChain4J supports all the kinds of signatures with Java beans and all other stuff. But here I'm going to use the simplest one, which is a string message input and a string in output, which is what the model is going to return. Okay. Once we have this interface ready, we're going to use, again, another concept of LangChain4J, which is AI services. AI services, that's the tool in LangChain4J that allows you to bind different components together. So what kind of components are we going to bind together? We're going to bind the chat language model with a chat memory, so that each user chatting with the chatbot is going to have its own memory of the ongoing discussion. And we're going to implement, well, LangChain4J is going to implement the contract that we define there, conversation service. Okay, so we give it this interface, and it's going to return an implementation. It will do the implementation on its own. No need to write it yourself. It's going to return an object that or a class that complies to this contract. Okay, and then because it's a chat, we want to send several questions, receive several answers, etc. So I've prepared a few questions. So the first one is just hello. So it's going to reply with hello, I'm here to help you, etc. And here, what's interesting with those few questions is that what is the country where the Eiffel Tower is situated? So it's gonna use its knowledge of the world to say, okay, the Eiffel Tower is situated in Paris, in France, where I live. And just to show you that it has the context of the whole conversation, the last question is, how many inhabitants are there in that country? So I'm not repeating the country. So I received, yeah, Paris, France. So I don't have to say how many inhabitants are there in France, but it knows about the context of that conversation. So Gemini knows that we're speaking about France. All right. So for each of the methods, of the messages, sorry, we're going to print the message and print the answer for each of those messages. All right. So that's what I was explaining. The LLMs are stateless. That's why we use the message window chat memory to keep track of the whole conversation. And here we're going to launch this command, Retrieval run-q and the conversation class. So let me come back here. I'm going to clear the screen. Retrieval run conversation. So let's see what it does. So you'll see up here the first question. user, hello. Gemini, hello, how can I help you today? So the second question that I'm sending it, what is the country where the Eiffel Tower is situated? Well, the Eiffel Tower is located in France, in the city of Paris. How many inhabitants are there in the country? France has a population of about 67 million inhabitants. Yes, that's a small country, right? And it says as of 2023 because it's knowledge cutoff date when the model was last trained on the corpus of data was at the end of 2023. So it doesn't necessarily have the knowledge of the latest events like who won the latest I don't know match, a football match or whatever, cricket match, whatever. So that's a conversation, and it knows about the context of that conversation. Are there, so just looking a bit at the chat as well. Resource exhausted, interesting. Yeah, the other thing is that the project we have, there's a quota, so you can run the model like a certain number or send requests to Gemini a certain number of times per minute. And if you run it too fast or too many times in a row, maybe you'll see some errors. Oh yeah, the environment variables were mentioned in step 3. Okay, so I won't repeat that. It's written in step 3. And the other errors, what do we have? Looking at the chat. Yeah, so you'll fail. It's not very descriptive. Yeah, not sure what those errors are because there's not much information. So you might have to run with the stack trace or info as it says, because I'm not sure what's going wrong there. Yeah. So about those few errors, are there people who managed to run this example and see the population of France? Some thumbs up. Yeah, resource exhausted, that's interesting. Okay. Yeah, and for those like the question, can you use LangChain4J only in Google Cloud? No, of course you can run everything locally within your favorite IDE. That's also possible. Yeah, resource exhausted. Okay, I know the projects that we provide. If it's not, so sometimes the quota are quite limited, and yeah, and sometimes when it fails, it retries to make the call. By default, there are 3 retries, so you might be seeing, yeah, retry failed, maybe once or twice or 3 times if you reach that limit. So maybe wait a little bit longer and rerun that, or just follow along the the video. I mean, without necessarily running the code. Okay. Is there anyone who actually managed to make it work in spite of the quota limits?
Show of thumbs. Anyone was able to complete till this step, please show thumbs up.
Okay, good.
Okay, perfect.
Some of you. So yeah, because of the quota limits, you may have to run the commands a little bit later on.
There's a send wait.
Sorry about that. Someone had their mic unmute.
Yeah.
So yeah, for those who are getting this quota exceeded or resource exhausted, please don't worry about it. It's not about the product or your implementation. It is because we are using this trial building account for this particular project, right? The link that you have received is for trial building account, and it is known to have such limitations. If you're using it with some other project, or if you're using it with your credit card, like if you activate the $300 credits, the free credits that you get as if you use your credit card. I'm not saying that you should use it. If you use it, you won't see such things. Or if you're using it in a production environment or a staging environment, which is an official billing account associated with it, you will not see such errors. This is only because this is known to be a limitation with trial billing accounts the small denomination ones that we create for events like this. So don't worry about it. If you got the answer once, just move on to the next step.
Yeah, and usually I see some people saying it worked, it works now, etc. That's usually because if you just wait a minute, you should have the number or the quote. Well, you're past that minute limitation, like X queries per minute, and it should just run after that. Okay, good. All right. So far we used only text. We sent questions. We sent hello messages and stuff like this. But as I said, Gemini is a multimodal large language model. It means that it accepts text, but also images, videos, audio files, etc. So let's go to step 6. I love cats, by the way, and here's a picture of a cat, right? So the fact that Gemini is able to understand, let's say, pictures means that you can ask questions about a picture. Potentially, it can do OCR, text recognition in pictures. It can say, okay, this is a cat who's walking on the snow or something. You can do lots of interesting things with pictures, videos, etc., and text. So, for example, let's say you want to create a travel guide, local travel guide. So you're visiting, maybe, I don't know, the Taj Mahal. You take a picture of the Taj Mahal and you give an audio file that says, hey, what is this monument about? And then you can actually pass audio, text, images to the model, and it should be able to reply. So here we're going to go through a simple example. So this is the multimodal.java class. So I'm going to open that as well here. I'm going to clear that and come back to the editor. I'm going to open it, multimodal. All right. So always some important imports, but here we're going to define the URL of our cat. So it's a picture from a cat taken from Wikipedia. As usual, we're going to define the model that we want to use. So as usual, the project ID, the location, the region of the project, and the name of the project. Here again, we're going to use Flash. Pretty much all the examples use Flash. And instead of, so you remember model.generate, you can give it a text prompt, but here you can also give some other kind of objects. And one such object is user message. In a user message, you can combine several things. You can combine text, and you can also combine images. So here I say create a content referencing that images URL here, right? And also the prompt, describe the picture. So Gemini will receive those two things at the same time, describe the picture and the picture itself, okay? And I'll pass the user message instead of the text prompt. But this generate method is not returning just a string. This time it actually returns a response object which contains or wraps an AI message. So we're not just going to print the string response. We have a higher level kind of object. And can I open it now? And the AI message has different fields and methods. And one such method is content. You're going to retrieve a content object which has a text method to retrieve the text of that content object. So it's a little bit different from what we were doing earlier. So instead of text, we pass a user message. We get in response, in return, we get a response of AI message. So let me run that in the terminal. Yeah, I'm going to, because I'm lazy, I'm going to copy and paste the command here. Command V, and let's see what it says about this little cat. All right, so it's starting, and it says, okay, the photo shows a tabby cat walking through the snow. The cat has a long tail, etc. Paws covered in snow. Background is blurry, is blurred. Yeah, and the cat is looking at the camera. It even gives the expression on its face. It's a picture likely taken in a cold winter day, right? So it's I think a good description of the cat that we saw here, right? So it's really able to provide you a description. So you can do Q&A on pictures and things like that. That's very interesting, the kind of things you can do. Yeah, what is Gradle? That's the build tool that we use in Java and the Java ecosystem. We either use the Maven build tool or the Gradle build tool, and this project uses Gradle. And if you write Android applications, they also mandate you to use Gradle rather than Maven. So it's just a build tool. What else could I tell you about this? Yeah, so you can recognize text in pictures, or even, you know, ask if the image is safe to display, for example, on a website. You can create captions for images, and you can also compare potentially images. So is it a similar image, or is it a picture of the same monument, or things like that. So I see lots of thumbs up. That's great. It means lots of you managed to run this. Thank you. So let's move on to step 7 now. So as I said in introduction, we estimate that the structured data that is available online or in the cloud or on your company's servers, etc., 80% of the data is actually unstructured and in the form of text, documents, and you know, articles, web pages, etc. And with an LLM, you can extract the knowledge within that text, or even within pictures, which is unstructured as well, and extract data that is in a structured way. So that's what we want to do in that example. So let's have a look at this extract data class. So the use case in this example is, so I'll show you this first. Let's say I have some document which contains a biography of a person. Okay, Anna is a 23-year-old artist based in Brooklyn, blah, blah, blah. And you want to extract the information about that person. And you want to have a proper Java object that you can use that contains the key information about that person. So that's why at the top here, I have a record, a Java record, that represents the concept of a person. So record person, and there are two key fields inside that record, which is the name of the person and the age of the person. So I want to extract Anna and 23. Okay. And for that, so as usual, we prepare a chat language model. What's new here is that I want a very deterministic output. So I lower the temperature to 0. And I say, really, top K is I really want you to look at just the first token that you can generate, not lesser probable words. So I want something very focused and descriptive and factual in terms of output, not something, because I just want to extract data from the text. And notice that this time, again, we define an interface to define the contract that we want to use, because the contract that we want to have is, okay, I have a biography in text form, but in return, I want to get a person record. So I'm not getting AI message response or string response. I want to get in return a person record instance. But I'm going to help Gemini a little bit. I'm going to add an annotation to that method, which will actually be the prompt used by Gemini to extract the right information. And what I'm saying here is that you should extract the name and the age of the person that is described in the string text that is passed, and return a JSON document that contains a name and an age, and return just JSON. Here's the biography of the person, and after that JSON colon stuff, the model should output a JSON structure of that represents the person. And it's actually LangChain4J that is going to do the JSON marshalling and marshalling to map the JSON text returned by the model into an instance of the record, of the person record. So that's why I'm nudging it a little bit to be sure that it returns JSON, so that LangChain4J can do the key mapping between the text and the right information in the text. Okay, so that's the prompt that LangChain4J will use to interact with the model. And then instead of there's just two things that we're going to do here. Instead of, like before, we were using a builder.build, etc. Here we can just say create an instance of that contract, person extractor, and you pass the model. But it's equivalent to say AI services, create a person extractor dot the model dot build, etc. It's just a shorter version of what we had in the previous examples. And then I can use that contract extractor dot extract person, and it's going to return the person. So let me find the command here, and let's run that in the shell, in the terminal. I'm going to clear. And what I like about this approach is that when you're integrating an LLM in your Java application, so as you can see, the output is Anna 23, and that's what we had in the code. Oops, sorry, it's I didn't reopen it. Extract data. Okay, as you see, I got a person object back, and I can just print .name .age. But that means that when you in terms of let's say the perspective of the Java developer, you're really manipulating Java objects. So maybe you're using Spring or a framework like that, and with dependency injection, it could give you a person object, and you don't really know that under the hood it's using an LLM like Gemini. So that's interesting, because you're using strongly typed objects instead of just text. All right, lots of fun stuff. That's great. Thank you. Okay, and yeah, a few warnings, but that's because sometimes, so you saw that I'm saying, yeah, generate JSON with that format, etc. Because I really wanted to generate the right structure so that LangChain4J can map to my records. So that's why there's this little warning box there. Step 8. So we actually saw a prompt template with that extraction there, because here what we had, the annotation, is actually a prompt template, because this yeah. Multimodality, can you integrate sound inputting as well? Yeah, so Gemini, you can give it audio files, video files, PDF files, pictures, etc. Yeah. Although, yeah, one caveat, the LangChain4J integration currently only supports images and text, but that's a limitation of LangChain4J. But it's going to be in upcoming releases. But if you use the Gemini Java SDK, you can also pass other multimedia kind of inputs. So prompt templates. the prompt template is really reusable kind of questions, but the same template can be used, but you can replace some particular variables in them. So for example, let's say you want to create a chat assistant that is a chef that knows lots of stuff about cuisine, Indian cuisine, French cuisine, etc., lots of cooking experience. You can prepare a template that says, here you're great at cooking, and you want to create a recipe. And here, look at this notation. That's the dish we want to create, and we have some ingredients, and also give a name to that recipe. So instead of just passing text or pictures and text, etc., you can pass some kind of structured text in a way. That's what prompt templates are. That's reusable prompts, basically, where you can fill in the blanks. So I have a chat model, well, with a few extra things mentioned there, like the temperature. I want something more creative because I want, fancy recipes. But look here, we're going to create the prompt, the final prompt, by passing variables to fill in the blanks there with the right values. So I want to create a dessert. So the dish variable here will be replaced by dessert. And the ingredients, I have strawberries, I have chocolate and whipped cream. So I'm going to replace, LangChain4J is going to replace ingredients with that list of ingredients. So I apply those variables to the prompt template, and I get a prompt. And we're going to transform the prompt into a user message. So that's your question to the model. And the model is going, and Gemini is going to respond with response of type AI message. I'm going to print the content, the text content of the content response. So let's run this. Open terminal. Let's clear the screen and copy that. It's going to compile and run this. So what do you think it's going to generate? What kind of desserts? All right, so all right, folks, gather for desserts, etc. Here what you'll need. So the ingredients, so there are indeed some extra ingredients, maybe like the lemon juice. So there's chocolate, there's whipped cream, and it gives you the explanations of strawberry swirl, chocolate layer, whipped cream on top, etc. You can create some, you can use it as your own cook assistant. All right. Do you manage to get some creative? And you feel free also to change potentially the ingredients if you want. Yeah. So a few hands up, a few thumbs up for generated. Yeah. And let me go back there. So I think it's step 8. Abby, you wanted to say about the screenshots and so on, or?
Yes.
Yeah.
Thanks, Guillaume. So this is the step which you will submit in your results screenshot for this session 2 of season 6. So what Guillaume is sharing in the screen right now is what you see from the code lab, the strawberry shortcake ingredients. So it doesn't necessarily have to be the same thing, but it's good if you have the same content, but you could have generated a similar one for a different recipe or something else maybe. But whatever it is, this is the screenshot we want for your results. Step 8, and right below the text that you're seeing there in the screen, you should see a generative output that looks similar to this one, right? So right below that one, that's the one. Cool. I have pinned this message in the chat as well. So, and it's also available in session description, so you won't miss out. And you'll also get this detail in the email.
Perfect. Thank you, Abby, for the explanation. All right. Next, step 9. I don't think we'll be able to go through all the steps. Text classification. Oh, there's a. That's where there's a double thing there. Okay, I'll have to fix that in the instructions. Text classification. So there's a technique called few-shot prompting which is a way to instruct Gemini how to answer, and the kind of tasks, the task we have in mind where we want Gemini to help with them. So for example, here I'm going to create a sentiment analysis solution. So I have a special prompt that says, okay, analyze the sentiment of the text below and respond only with one word describing the sentiment. For example, we give we say few shots because we give a few examples of input. This is fantastic news. Okay, that's positive. Pi is roughly equal to 3.14. That's kind of neutral because that's just a fact. Or I dislike pizza, especially pineapple on top of pizza. That's disgusting. So that's negative. And in that prompt template, we're going to replace with whatever you want to put there. And we are going to ask Gemini to reply with something like this, basically. So output column, and it should print positive, neutral, or negative. So I'm going to pass and replace the text variable with I love strawberries. So hopefully that's kind of positive, right? And I'm going to, again, generate the message prompt. I transform the prompt into a user message, and I receive an AI message wrapped in a response, and again, printing the text of the content that is returned. So let's see that in action in the shell here. So strawberries, is it loving strawberries? Is it positive or not? Hopefully it is. It is positive, right? So that's great. It's positive. Strawberries, if you love strawberries, that's positive. Any thumbs up for this example? So that few shot prompting, that means instructing the model to reply in the way we want it to reply. Because if I had not done this trick with input-output, it would have been something, the response would have been something like, hey, yeah, that message sounds positive, or Gemini would have replied with a longer answer. Here, we really just wanted to have one message. So we still have a few minutes. I'd like to go through at least step 10, which is about an important concept, retrieval augmented generation. It's the fact of helping a large language model go beyond what it knows, what it's been trained on. So for example, if I want to chat with my corporate PDF files, it's not been Gemini has not been trained on that content because it's not public information. That may be a private information. So there's a way to circumvent the fact that large language models can't know about everything, especially private information. And there's one pattern which is called retrieval augmented generation. So let me explain how it works. There are actually two phases. So we'll look at the diagram, and you feel free to read the text afterwards. There are two phases. The first phase is we're going to look at your own documentation. We're going to take all the documents and split them into small pieces of text, usually a paragraph long. And we're going to do something which is calculating vector embeddings. That's a vector representation of the text. And that's a particular model that we can use called an embedding model. This is not Gemini, but under the hood, Gemini uses something like this in its neural network, actually. But we're going to create vector embeddings, and for each vector associated with the text chunk, we're going to store that in a vector database. So it can be something like PostgreSQL, which has vector support, but it could be vector search, which is a vector database that's available on Google Cloud, and PostgreSQL is as well, etc. There are different databases you can use. Here, we're going to use just a small in-memory database. So that's the first step. The second step is the querying. So you just have to do this ingestion once. And then comes the querying phase, where the user comes and asks a question, a prompt. And we're going to do the same setup in a way, because we're going to calculate vector embeddings for the query, for the question. And what's interesting with vector embedding is that the question that is asked by the user will have a vector that is quite close to the vectors and thus to the snippets of text in the vector database that are semantically similar. So the vector of a question is similar, is close to the vector of the chunks of text in the vector database. And so I'll spare you the details with how it's calculated. It's a little bit complicated, and I must admit that I don't really know exactly how it works. But during its training, it's seen lots of association of words, etc., and it builds a kind of probability vector of how words are interrelated. So I won't dive much deeper than that. And the vector database can return like the most similar vectors, and we're going to fetch the snippets of text, the chunks of text that correspond to the closest vector. And we're going to pass to Gemini the user query, and we're going to say, base your response on those snippets of text that we found that are relevant for this user query. And Gemini will reply with that context information with the query and with the information that's actually only part of your document and not part of the general knowledge. So how to do that? So we're going to have a look at this RAG class. RAG.
So just one information. So we are at time, steps 10 to 13, you can just listen in because we have to, our important focus for hands-on implementation was until step 9. So from this point, it's informational and it's really interesting concept. So don't miss out on Guillaume's walkthrough of the code.
Okay.
But so you can, you all can.
I have a few more minutes to at least finish that one, or?
Yes, okay? Yes, you can. Yeah. Please take the time to finish it because there's a lot of folks who are interested in those 3 concepts. Cool. So this will be informational though. You don't, folks on the call, the developers, you don't have to actually do it hands-on at this point. Feel free to listen in because it's nice to understand the concepts first. We have detailed sessions for these topics coming up through the season. So,
all right. Over to you. Thank you very much. So as I said, there are 2 phases. So I'll take an example, a PDF as example, which is attention is all you need. That's the research paper that Google researchers created and wrote when they invented that transformer neural network architecture, which is used by all the large language models today. So I'm going to ask questions about that particular PDF document. So what we're doing here is that we're loading the PDF document. We are going to define, so this time that's not the Gemini model. We're using an embedding model, which is called Text Embedding Gecko version 003. And this is the model that is going to return vectors of numbers, of floating point numbers. It's not generating text, it's generating those vectors that we store in a database. Then so we could use PostgreSQL or other databases, but here we're just going to use an in-memory database. And it's part of the LangChain4J project. So we prepare an in-memory embedding store, as they call it. And look at this. We're going to combine the vector database, the embedding model, and look at this, a document splitter. We're actually going to split the document in chunks, and it says, okay, split in chunks of 500 characters, and maybe with an overlap, of 100 characters, so as to not have words cut in pieces, right? So 500, but with a small overlap of text. And then you should see here the ingest method. So that's that's at that point that it's going to calculate the vectors for each of the chunks and store them in the vector database. Now we're good. That was the ingestion phase. Now we're coming to the querying phase. So that's where we're going to need the Gemini model, as before. We're going to create what we call a retriever. So it's a way to say, I want you to retrieve information and relevant excerpts from the documentation from the vector database that contains the vectors, and the associated text chunks. And now we're going to create an AI service. So we have, I think the interface is there. It's a simple interface. Ask a question, return a string. Okay. We're going to create, let LangChain create an interface, an implementation of that interface. That's my LLM expert. So it's an expert in large language models because it's able to answer questions about the architecture of large language models. So we really combine those things together: the model, the chat memory, because again it's a chat conversation, and the retrieval. And potentially you can further tweak things. So here I'm using the default prompt template that comes with LangChain4J, but I could define my own custom prompt. And this is a similar prompt that LangChain4J uses by default, but here I'm saying, you're an expert in large language models, you explain things clearly, etc. So here's the user question, and it's a prompt template, so it's going to be replaced by the user question. And answer using the following information. So it's going to put the chunks of text that match the user query. And then, okay, I can run it, but I've got several questions about large language models, and if I run that, but it's right there. Just want to run that in the terminal. Clear and paste, and you're going to see it's going to reply to my 4 or 5 questions that I have, 4 questions that I have about large language models. So let's see the first one. So it chunked and created the vector database and all the vector embedding. Now it's time to answer the question. You can see, okay, first question, second question, etc. So it's replying to the question progressively, but it's based on the document. So that's so I'm going to stop it now, but it's really a way to be able to palliate the lack of knowledge of an LLM about your private information, your personal documents, etc. So that's a very powerful concept. All right. So shall I stop there or mention the other ones, or just briefly if attendees want to have a look at them, or a quick description? Abby, what do you want me to do as we are at time?
We can stop here.
Okay.
The next I think we have function calling coming up as session 4 of season 6.
Nice.
4 or 5, I'm not sure. So yes, definitely we'll discuss function calling soon. But for folks who are interested to execute the last 2 steps on your own, feel free to follow the code lab. But for the session, we'll stop here. And also for all questions related to, errors and other things that you're facing, if you're facing build errors, please don't paste the error message that you're seeing in the Cloud Shell terminal. Go into the build logs and see what exactly is the error message you're getting there. Because more often than not, you will be able to identify how to fix it on your own by just looking at the detail of the build error, rather than just saying that you have an error in the build, right? So we can't do much with that information. But once you identify the detail of the error and still not able to figure that out, use the Discord channel to ping us, and we'll help you with the details. All right. Thank you everyone for attending. Thank you, Guillaume. This was an amazing session. Show of thumbs, how many of you were able to complete till step 8? Yeah, if not, also you have time until we start the next session. You can still submit until June 30th. That's our last session. That's the end of this season, so you will be able to submit results until then. For any issue with respect to previous sessions, result not getting accepted or something of that sort, feel free to ping me or ping in the Discord channel. We'll be able to help you. You will get the recording link, and you will get a new credits link in case all the other credits links are used up and you're getting error message while activation of billing accounts. You can use the new link that will be sent to you tomorrow morning along with the video link. So you can complete this at your own time, and also submit the results screenshot until the end of June. So that is it for you. And I've shared Guillaume's LinkedIn link and pinned that in the chat, so you can find it there, and you can also connect with him and ask him any questions. And if you have any wish list for LangChain4J, he's also a contributor, and you can always ping him for that. I hope this was a useful session for you all. I'm going to stop recording now. So feel free to ask any questions in Discord channel. I'll be closing out the meet soon. Thank you, everyone. Thanks, Guillaume. And thanks to all the community leads and other Googlers who are also part of this call and helping out with answering questions, Code Vipassana community leads. Thank you, everyone. Thanks, developers, because you've been relentless through the seasons and you're continuing to give us your support and also stay very enthusiastic for the learning, and that's really important for us, and that keeps us going too. We'll come up with new use cases, we'll come up with new themes, new seasons, and you will get to learn and try out everything that's latest and greatest, and the things that we get access to and the things that we get an opportunity to learn and appreciate, we want to bring those things to you as well. So that is the overall objective, and I hope you enjoyed this session. Thanks again, Guillaume.
Thank you, everyone. Goodbye. Have a great evening.
Thank you.